This is unit 4, lesson 7. So this is the part 1 of graphing. So we are doing the investigating the graphs of polynomial functions. The biggest thing to know on these is the fill in the blanks the following statement regarding the function of y equals p of x. Okay, the zeros of the function. So we got the zeros. There's the zero of the function. I guess you can say zeros, it doesn't matter. The x-intercept of the graph of the function and the roots, we've hit this far too many times, are corresponding to when y is equal to 0 are the same numbers. So when we find these things, those are important for graphing because they're landmarks on the x-axis. So when you have your zeros or x-intercepts or roots, those all cross the x-axis, same point. Okay. The unique factorization theorem. This theorem states that every polynomial function of degree greater than 1 can be written as a product of leading coefficient c and n linear factors to get. This is just saying that you can break your factors down depending on how many degree it is. So I have a cubic, you could have 3 factors, quartic, you could have 4, etc. This theorem implies 2 important points for polynomial function of degree n greater than 1. So point 1. Every polynomial function can be written as a product of its factors and leading coefficient. Okay, every polynomial function has the same number of factors as its degree. The factors may be real or complex. Now that's important to know because if you're saying, well, wait, not everything's factorable, you're right. If you have a cubic, that doesn't mean you have 3 x-intercepts. It means you can have 3. And then what happens is, and we get into this imaginary world, of when, I think it's going to get into it. If not, I'll just give you this quick little run through. Whenever you get the point of like, if we get to this, we know we can't do that, right? And so in math, just the little, I call it the hiccup of math for radicals, is that they call square root -1 is I, which is an imaginary number. So it's not real. That's why we've been saying real numbers all the time. And so this would be plus or minus 4i is what the square root of -16 is. And all that signifies is that the roots and x-intercepts aren't real answers, so it doesn't happen. Okay? So all I'm telling you is that when they say they can be factored, it can be factored, but it may not be real factors. Okay? So that means it doesn't cross. Right? So let's look at that. Okay? All right, so this one here. We have x squared minus 2x squared minus 5x plus 6 is shown. The polynomial has integral 0. So we can see 1, 2, it's got 3, so that's nice for a cubic. State the zeros. The zeros give some nice even ones. -2, 1, and 2. Oh, 3. Oh, thank you. Yeah. Told you I'd be off today. So we have -2, 1, and 3. Thank you. So then state the factors. Now once you see it like that, your factors should be pretty straightforward, right? Your factors are going to be x plus 2, x minus 1, x minus 3. Okay, and so then in factored form, it would be the polynomial is just kind of the same thing. Okay. It says use a graph calculator to sketch p of x in expanded form and in factored form to verify the above answers. So all that means is put this in your calculator. I think this is fine. I think you guys can do this. I'll pause the video if you want to do it for a second, but you're just putting this in y1, and then you're putting this in y2 and just seeing they're the same thing. Okay, just seeing they're the same thing. So we'll pause it. So this is already almost done, guys. Super short lesson like I told you. Just have this little piece here is all. Okay, so use the graph calculator to sketch the graph. The polynomial -x cubed plus 4x squared plus 7x minus 10. Use the graph to state the x-intercepts. Write the polynomial in factored form. Okay, so let's go ahead and I'll graph this with you on the calculator. Here's mine. Might have to go bring him up here just a second. Okay, so let's go ahead and put it in here. So we got -x cubed. So -x, wow, Okay, negative x cubed plus 4x squared plus 7x and the minus 10. I'll have to adjust my window. Yeah, I want to make it a little bit lower and a little bit wider. So let's go negative 10 and 10. And let's go a little bit lower, so let's go negative 20. I want a little higher too. Let's go 20. I'm going to go by 2s now to make it a little bit like zoomed in a bit. There we go. Okay, so we can see our zeros. So it wants us to find these zeros here. It looks like it does cross all the way like smoothly. You could confirm that with the zero method, but just for sake of time, this is at negative 2, this is at 1, and this is at 5. Okay, so that's your zeros. So since that's your zeros, we can go ahead and on here. We have our zeros were negative 2, 1, and 5. So the graph looks like this. Comes through negative 2, 1, and 5. So here's your negative 2, 1, and then 5. That's what the graph kind of looks like. So then write the polynomial in factored form. So that means in factored form we can write it as x plus 2, x minus 1, x minus 5. Okay. All right, so then it's just answering things about this graph. The left side of the graph, when it's coming from the left arm, so this right here, when it's going this way, it's rising. Okay. The right arm of the graph is falling. The degree of the polynomial, is it even or odd? Odd. Good. And then the leading coefficient of the polynomial is negative. Okay. So the kind of investigation assignment in this lesson will develop the relationships between the directions of these arms in the graphs. So when you're going through these, it kind of shows you normally, okay, normally a cubic goes like this. So it falls and rises, but that negative flipped the in behavior. So we're going to focus on the in behavior for these graphs. Okay? So the in behavior for a normal, what I was trying to draw there, you can't really see the lines very well. This is the regular cubic graph. What I mean by that is regular with not a positive. And so normally we expect it to fall to start, rise to finish. This one rise to start, fell to finish because of the negative. It flipped it in terms of its behavior. Okay? All right, we'll stop there for that one.